Now, when experiencing problems with your idle air control or experiencing high or low idle, this right here pretty much determines what the idle is going to be. Now, normal things that you'll notice when you've got a high idle is when you come up to a stop sign, it seems like the brakes is just not holding like it used to. And if you come off a hill, it seems like it wants to coast faster than it normally does. And this will cause the trans brake and the engine braking not to work. So when you test driving it, or if it's your vehicle and you're driving it and you do notice it's wanting to pull through a red light for no reason, or like your brakes is not holding like it used to, this is one of the conditions that causes, if you got a high idle, it's things that you'll notice that you can't control. Now, if you notice these conditions, I'd lean more towards throttle linkage, throttle cable, something like that, or the pendulum is not able to close on the idle air control motor. If you notice that it happens sometimes and sometimes it don't, it's kind of erratic, then most likely it's the throttle linkage cable, throttle plate is hanging up, not closing all the time. If it was a pendulum that wasn't closing all the time, like your idle air control motor, once it went back to working, it would get rid of whatever hung it up in the first place, and it would probably only happen once. If it's a circuit, it could be controlling the idle, not controlling the idle. So in this video, we'll eliminate the circuit and the idle speed control motor. That'll take something off our plate. Now, when this is not in control of it, this cable, either one of these cables, if they're too tight, it'll hold your throttle. So you need to make sure that your throttle is all the way on base, and they'll click. You notice how that clicks? That says that it's stopped because there's an idle base screw right there. And see how it stops? That'll stop it. If this is bent, or if your linkage is hanging up like mine was, if you feel it grab there, then you've got your butterfly throttle plates are not lined up. They're a little side to side, and they're catching. And what I done is I cleaned the sides, cleaned all the carbon out of the sides on each side, and that stopped that. After cleaning your throttle body, you'll get a better response just from cleaning the throttle body. This is the cable to the cruise control, and the other one goes to the pedal. This is your idle control motor here. There's really only one way to test it, and it's just to test the continuity between the two poles to see, because this is a stepper motor, and with a stepper motor it don't actually wind out like a regular motor, like your window motor, wiper motor. What it does, it takes it in increments. Powers up one side and it'll step out one step, then it powers the second side, steps it out again. It can control the precise increments, and then it can count how many steps it's went out and come in. The higher number is the further in it is, the lower number the further out. And in order to retract it, it does the same thing, except it changes the poles. Where this is positive and this is negative, it'll make this negative, that positive, and it does the same thing. You can take your scan tool, but your scan tool's got to be bidirectional. And when I say bidirectional, that means that it's got to be able to actually, as well as communicate with it, it's got to be able to give commands. A typical scan tool, if it's not bidirectional, with ESOs, it checks all the modules, but it's not bidirectional, so I cannot command, and you won't be able to command it to do anything. Now let's go into live data. If you look at live data, it shows us that our idle air control motor is at 0, and we know that 0 is as close as it's going to get. So it's done all it can do as far as the computer's concerned, and that's why it says it can't control idle. A simple way to check your harness, we can do that next. We can take a test light. Be sure not to put it on the hot side, because whenever you're doing anything, you do not want to introduce voltage, of course, to a circuit. If you'll put one end on the ground side, go to any one of the 4 terminals right here. Unless there's something wrong with the ECM, that wire, if it can make it hot, it can also make it ground, so you don't have to worry about that. I mean, that's just overachieving. So you just want to make sure that your test light's working first. We know it's good. Know we got a good ground. Now then, after starting the engine, we're going to take and disconnect our 4-pin connector. And we're going to check each one of these to ensure that we have a light flashing while we take and accelerate. So now we want to check our circuits on our pins. After the engine is stabilized, we're just going to take and disconnect our connector. And what we're looking for is a flashing light on our test light. It shows activity on A, B, C, and D. So thus far we have checked, we know our circuit's good. Now I always want this plugged back in before I turn the engine off, because it's already set and it's probably around 30, and I don't want to confuse it. If you do it when it's turned off, it'll try to take your idle air control motor to 58, 60, and because it's not hooked up, it didn't take it, so it don't know it hadn't been set to 60. And then when it starts up, it'll try to die until it relearns home again. When you're testing the idle air control motor, you're going to test the two outside ones, the two is closest together. You see if the resistance is close on both circuits. You can test it off of your old one, or between your old one and a new one if you decide to. But if it's open, it's bad. If it's not and they're really close, and I'm talking 5 ohms, if it's got a big shift in it, then that's something to be concerned about. They'll melt it together, and if they are, then resistance will be low. And if they're open, some of the windings would burn out, then your resistance is going to be real higher than the other one. In most cases, it don't take both sides of this circuit out. So if you've got one that's got a huge difference in the resistance, this is going bad if it's not bad. It may still be able to do part of its job, and you may not have everything fixed yet, but that's a way to check this. If they're close, then that's going to confirm that this is okay. Now, all that does is tells us the windings are good in this. It doesn't tell us that this ain't stuck and won't move in and out. Remember, when you're running any test, make sure all your loads is off, your AC, anything that may cause idle to change. You want everything to be at base. Now, if you see here, we've got a high idle speed high, last test failed, ignition not run. This time, since it's been started, it hadn't run the test. But at this time, if you look, we won't have a check engine light. It has to run, it has to see it twice in 2 consecutive times in order to set a check engine light. So the last test failed, this test failed, that's 2 tests. Now since it run it this time and it still continued to see the problem, it turned the check engine light on. Let's look at freeze frame and see what we have. Now here's where it's important. Okay, coolant temperature was 197. Look at our fuel trims. You'll notice our fuel trims was within, hovering around 0, so it's not a vacuum leak. Our engine speed was at 904 and it was looking for 575. Since it done it this cycle, let's see what's going on in the live data. Okay, we're running around 1,000. The idle position is count, it wants it at 0, so first thing I'm going to do is first thing I want you to do is see if the linkage is hung up. So you want to see if it's going to pop. Don't hear that pop. Let's just put our finger across here and see if it'll idle that. Uh-oh. Something is keeping these throttle plates from holding these throttle plates up. Now it could be the throttle is not centered. Now the first thing I want to do is I'm going to take this air horn off and take this hose bracket loose here, and we're going to look at the throttle plates and see if they're centered up. First thing we'll remove, we're going to loosen these two number 8 hose clamps. Now we'll remove our hose bracket. Now we should be able to just gently slide this forward and pull it off. We'll take a look. Now in case yours is like mine that pulled off with the throttle body, you've got 2 notches there on the bottom and that to line it back up. Now that gives us access to our throttle bolt. That's your base idle bolt. That's where it should stop. You'll notice it's not hitting it. So, well, right there. This cruise control cable is too tight. So what we'll do is we'll just loosen it up. We want a little bit of slack in it. And then that way our cruise doesn't try to lunge up and down. If it's got too much slack, your cruise will start hunting for its speed. Now let's see what it sounds like. All right, we know it's at base, and if you'll notice it, we lost our little groove there. Now, here's another thing you can do is check and make sure it's free. You should be able to lightly push it and start opening. If you feel it hang, where it'll kind of grab and then come open, something is binding this throttle plate, and it's probably, if it's got a lot of corrosion on either side here, it's sticking it to one side and it'll cause it to not want to go, not be in center, so it's not going to seat and it's going to want to grab on you. Now we know that was our issue, or at least now we can rerun it and see what our idle does now. Now I have just a little bit of assembly lube around that. That'll keep it from wanting to roll. Slide right on there. Now if you install this first, makes it easier for the rest of it to go back together. And remember, this hose may still be hot. Now check and see if our hose, we'll make sure that our hose seal is not rolled. Because if it is, then you're going to get a mass airflow code. And don't forget to tighten your clamps back up, or you'll get a mass airflow code on that. Our purpose here is to make sure we don't add more codes where we think we're fixing something else and we add something to it. Now, we're not going to want to clear our codes, but we can see if it clears out. So what we're going to do here, now we're going to look at our engine data. And we know normally our idle air control motor runs around 30. So what we're basically going to do is look at our idle air position. All right, let's look for our closed loop. We know that's still going to be on. Let's look at our sensor angle. Now we're down to about 0.6 since we took care of that. If you remember, it was 7.6 or 0.76. And as long as it's below a volt, it's not going to set a code on that. Let's go ahead and keep in mind to see if any of this changed after we fixed that, because we don't want to set a code for a lean code. We're still in open loop. It says IAC position desired 66. Let's start it up and see what happens. Now it takes at least 3 engine cycles before it'll turn that light off. But we'll know if it's fixed beforehand. And we can do that with our scan tool. Okay, we're running 588. IAC position, desired position is at 55. We're in open loop. So we're going to run it until it goes into closed loop. Our malfunction light is still on. Right now we're still good on our fuel trims. We're running around 0. So we'll let her warm up and go into closed loop. Well, it's gone into closed loop. We're still looking good on these. We'll see what our idle air control motor makes it down to. Now if yours is real dirty, go ahead and clean it. It'll be a good time to clean it. Mine, if you noticed, I'd already cleaned it. The desire here is to look and see our speed. 575 is where it's looking for. We want to make sure we're at 195 degrees. We're running close to 34. The malfunction light is still on. And we're hovering we're still showing it's a little rich. Let's check and see our trouble codes. Now what I want to do is I want to look at freeze frame. Now what I want to look at is diagnostic info. Okay, 507, if you'll notice it dropped down. It means it wasn't the top code at this time. Alright, this ignition passed, malfunction still requested. So our last test passed. Now take up to 3, you can take up to 3, we'll see. So I feel confident that we did fix the issue. Now let's look at our engine speed is good. Coolant temperature is where it failed the last time. Our desired and our IAC is running around 30. Throttle position sensors above a 1/2 volt, we're still good there. Loop status is closed. Malfunction light we know is on. And our long and short-term fuel trim for left bank and right bank is still running. Short-term fuel notice it's running around 0, so it's not going to go a little higher than 8. Now if you'll notice, we've got our long-term is running about -6. You got to think about it. The evap canister is venting, and the evap purge is running about 18 of 100%. So it's actually pulling the raw gas into the engine and burning it. And then ECM is also saying we're venting, we're pulling in raw fuel, we won't set a light for rich condition. Rich condition is still controllable, so it's within controlling. So while this is venting, it will bring our long term up just a little.